so I'm going to start recording. Great, cool. So the main point of today is to review SQL. I can do some of this stuff. I was hoping some of you or maybe I'll control it. I'll just ask for individual volunteers. Yeah, that makes sense. But we're going to want to go over some of this stuff. So let me just I'm going to put this document to the side here, and then I'll open up a terminal over here. Nice to have your own full terminal, not just the VS Code when doing SQL, in my opinion, because there's just a little too much information to fit in a small window. And actually, I need to remember, how do I get into SQL from here? Do I need to, there we go, brew services. Let's say restart Postgres. Restart will stop it if it's already running and start it again. And it's good to do that if you haven't touched it in a little while. It's not necessary, to be honest. And then once I run that, I should have access to the psql command. And then I give it this thing called Postgres, which is like the name of the user. And that's who all the databases are associated with. So I do that, cool. And then from there, I don't remember a lot of these commands, but if I say /d, it'll tell me all the tables I currently have on here. Does anyone know off the top of their head, is there an easy way to wipe out the whole thing? I guess that would be, I would get out of here and say destroy database or something.
Drop, I think drop.
So first I'll get out of here. I did Command D, I guess /q is what psql expects, but I have stuff in here I don't really care about. And I would say when you're in the learning phase, don't worry about destroying a database outright. Like you don't need to keep this stuff around. It becomes very important in the real world. But generally you're going to have a distinction between like a development environment, a test environment, and a production environment. And the only really important thing is that you're not destroying information in the production environment, because that might be a real person. And if that real person has like, information, like, past orders or something, you don't just want to lose that information. So people are very careful about locking down production databases, but while you're learning, while you're on your own computer, it doesn't really matter. So it's drop DB, right? There we go, drop DB. And then I guess I give it the name of the DB, and the name of the whole database is Postgres, right? Is that correct?
That would be the database engine.
Okay.
The name of the database itself, there could be a database named Postgres in there. That probably actually isn't the one we want to drop. Postgres uses
/L databases.
Yeah, /L. If you want to pop back into psql, /L will give us a list of all the database names.
That makes sense. So I go in here and I say /L. See, I often don't know about a lot of these. So right, so I have one database called Postgres, one called template 0, and one called template 1. That seem right? I don't really know about template 0 or template 1, but I'm going to delete that Postgres one.
And yeah, there's a database named Postgres in there.
Yeah, I mean, that maybe is a little annoying that is the case, but
that might be the one database we don't.
Okay, I'm a little
to
confused
delete
myself. Yeah. So,
no worries.
And of course, I don't have to drop those existing tables.
I see Daniel has something to say.
Yeah.
Okay, go ahead.
Don't drop that database. If you drop that and you do PSQL space Postgres to like go back in there, what you're doing is you're at PSQL. When you say space Postgres, you're actually loading the PSQL terminal or the shell within that Postgres database. So if you drop it, that command's not going to even work anymore.
Got it. So that
don't do that.
That database called Postgres is like
it's like a placeholder almost for the super users Postgres.
But it seems like, right, it's sort of like the kernel of our operating system, in that if we deleted it, nothing would work.
Right. Yeah. Right.
Okay, very good to know.
Yeah, you hit the nail on the head.
It probably would have let me delete it. And it's always good to remember that with computers, you're often given powerful commands, and they expect you to be smart. and it's easy to copy something online or just say, oh, I named it Postgres, right? I must have. Let me delete it. Cool. So maybe I'm not going to, I would love to, I'm just going to go into PSQL.
You could just
Postgres.
add some other database real quick, an empty one or whatever.
Yeah. Oh, I see. I'm
demonstrate
in
the
there.
drop
So if
thing.
I say /d, what is /dt? What's the difference? I don't know.
The tables.
Tables for a database, I think.
Got it. So we're not seeing any of these sequence things, which if people are confused, the sequence thing has to do with associating one table with another. It ends up being a separate table essentially, but it's not a table you store things in. It's just how PSQL handles the lookup between those two tables for when you have a foreign key relationship. So it's often there, but yeah, so I'm just going to quickly say drop table, right?
Drop database, and then the name of the database. And if you want to, you can add if exists at the end, and then top it off with the semicolon.
I'm a little confused. What is I thought we didn't figure that out. What is the name of my database? All I know is that I have a bunch of these tables.
Oh,
right. That's why I was saying you want to create a database that's worth safely dropping. You don't really have anything valid to drop at the moment, database wise. I don't know what those templates are. You could drop those, but smoke might come out of your tower. I don't know.
Right. So
I'm not sure about the templates either.
Yeah, I would.
So you're saying the first thing I want to do.
Those three come pre-installed with that Postgres server app. I would leave them alone.
So you're saying start with create database, and that's something you can do within Postgres?
Yes, sir.
Yeah, it should be. I don't know the syntax. I always do it from the regular Linux shell, but I wouldn't touch those three databases that are sitting in there. That's a recipe for disaster.
That's exactly it. Create database and the database name and colon. Yeah, and the context here is that PSQL is sort of our command line interface with the whole Postgres database engine that lets us manage multiple databases that Postgres, our DB engine, may be running.
And now how do I switch into that database?
That one, I always have to Google the
command
for.
It's /C space the database name.
Yes, sir.
Great.
Thank you.
I think it's like checkout database or whatever. Yeah. So
yeah.
now changes to review.
Yeah. So initially we were in the Postgres database. Now we're in the review database. And if I were to say within here /D, it would show me all my tables, of which I have none. Great. So we're in a blank environment now, which is good. So yeah, what do I actually want to do? Well, the first thing to discuss here is select, but it's not really reasonable to discuss select without first discussing insert, because we have to actually have something in there. And it doesn't really make sense to discuss insert until we discuss creating it. So we'll just start there. I have this totally blank database now. So this represents something that is, I'm in a space that understands SQL, but it has no tables in it. So what is the first thing we might want to do? And let's just say, based on what I'm reading here, it seems like we're talking about students. Students have this information. What else? Yeah, so I'm fine with this students lockers thing, and lockers are their own thing. So we're going to use this doc to try and create, that that schema. And to do that, maybe I'll create a little file schema.sql. Maybe I'll call it even review schema so I don't get confused. And I'll just save it exactly where we are right now. And I just want to see if I wrote create table, am I getting it right? Create table, students. And I'm just going to say every student has a name, which is a varchar of 255. And it's not null. And I'm going to say that's the only thing. Actually, might as well give it an ID. It doesn't really make sense otherwise. It's also going to have an ID, which is this serial thing, which is, just a positive number as far as I know. And instead of saying not null, we explicitly say that it is the primary key. And that way it will update each individual ID as we create one, and we don't need to be explicit about it, and then semicolon at the end. So I'm going to save that. And then from here, how do I run that file? Do I have direct access to the file system, or what is
I actually did.
You can copy paste.
Oh, go ahead.
I could copy paste, you're right. But I want to have it in a file so that I can keep making the file fresh. So, so I can say before this, like, drop students if exists. And this way we can make changes to our database that, I don't know. I like this method in terms of,
let's try,
it's easier to edit things.
If you want to pop open a tab with the command line or pop out to the command line, I have a link for how to do that one outside Postgres.
Yeah, didn't a student just do it inside?
I think it was
I'm
slash
looking at that
I
as well.
slash
I.
It's a
Slash
push
I.
path.
I knew there's
Yeah,
a
good call.
/I probably means /interactive or something. And then after /I just give it the file system location. So will it know // // seems to be the root of my file system. So I can say // so first, this is a useful tip, just like you have Control-C and Control-D, which are useful for exiting out of something. A command that is often respected across all sorts of programs is if you want to clear the screen, normally in the terminal environment, you could write clear. P-SQL doesn't understand clear, but it does respect Control-K or Command-K. And there we go. And now I can see my whole screen again. So that's a useful one, Command-K. But here I'm saying, okay, interactive /Tango /curriculum /week 5, right?
I have a tip for you.
Okay, what's the tip?
You can go to VS Code, go to the file thing, and then right click the file and just copy path. If you go to the icon on the top left,
The actual file explorer on the left.
see.
yeah,
Over
there
here,
we
too,
go.
right?
You
Copy
could do
path.
that.
Yeah, copy path or copy. Yeah,
I got it. So I could do that, and then this will give me a total path. So that is the absolute path from the root of my file system. And that all looks right. So let's try it. And it says doesn't like that. What is it actually here? It's drop table students. What's the syntax?
It should be drop table if exists students.
Okay, so the if exists comes before. Yeah, basically I forget the syntax sometimes. There's a lot of syntax to SQL. It is its own language. Let's try that again.
Agreed.
Okay, drop the table and then created the table. And then from there I could say select star from students, and I see I didn't spell select right. But this should give me all the students, which is no students, but every student has an ID and a name. Cool. So that being the case, let me go back to the lecture content. And yeah, so we're saying select is, how we get information, but it's a little hard to think about or work with select until we've at least done insert a bit. So the next thing we're going to do is insert some stuff. And so I'm going to copy paste this because this insert, I'll do it after I create the table, but it's also going to inform what creating the table should actually look like. So if I look at this, I'm going to see, okay, right. The syntax is insert into, then the name of the database, in this case, students, and then all the fields we want to update. So in this case, we want to update first name, last name, birth date, locker ID, and then finally our values. And it looks like you can give, multiple entries at the same time. So this would represent 4 individual students. And yeah, so how might we want to represent this? Well, the first thing, we definitely have that ID in there, but it looks like we have both a first name and a last name. And so I'm going to update what my schema looks like. So first I'm going to have, and the reason we're able to do this is because we're going to drop the table initially anyways. So it's as if we're creating a new table. So here's our first name, and it can't be null. That seems to make sense. And varchar 255 seems good, because how long is a name really going to be? I've seen some of you doing like varchar 20, varchar 40, which is totally fine, but don't be afraid to use up all the space varchar gives you. The important point is that you're not exceeding it. So you do want to be careful if like someone could have a name that exceeds, 40 characters. It could happen. Whereas a person probably won't have a name that exceeds 255 characters. And that's a legitimate thing to say. That's the cutoff. Beyond that, we don't accept names. We don't accept long names. But this is just the first name and the last name. And then after that, we have the birth date. Again, I feel like birth date should not be null. Everyone should have a birth date. And the birth date, what should the type be?
Date.
Date, yeah. So I knew that this is the real benefit of Postgres in particular compared to SQLite or MySQL or the other ones. It's got all these built-in types. So we can look up this date type. Let me grab a new window here. So if I said PostgreSQL date type, yes, we have these date and time types, and they get into it a little. But let's see if I zoom in here. Can I zoom in? It's not okay. I want to see an example. I hate when docs do this. How often? I'm sure you guys all feel the same. How annoying is it when a doc doesn't just give you direct examples? I see this is giving me a lot of direct examples, but I hate when I just get information. So yeah, it looks like our dates are going to be year, month, day, I'm guessing. It's I'm not sure what that format is, but it looks like all of that. Yeah.
I think that's correct. I've got a good link I'll throw in the Zoom. Yeah, and I think we can roll with the date type, and I think you're correct that the year, month. Yes, exactly.
Yeah. So it seems according to this example that the default desired format, ISO here stands for like International Standards Organization. It's an American organization that defines standards in terms of like, oh, this is what, JSON should look like. This is what JavaScript should look like. There's different standards out there. But like, for example, like when we talk about JavaScript, that's the ECMAScript. That's just a European version of a standards committee. But right, so there seems to be a desired standard that looks like this: year, month, day, and that's what we have here: year, month, day, and it likes that. And so if I just give it the date type, it sounds like it will understand that. Okay, and so that is going to be the date type, and then finally, it looks like we have this locker ID. So we haven't created the idea of a locker yet. And we will, and it sounds like, well, we're going to have to create it before the students because every student relies on this locker. But for now, we're just going to say we have something called locker ID, and eventually we'll add that foreign key constraint. But for now, I guess it's just an integer or maybe a serial because it represents an ID. And let's say it can be null. It doesn't really matter. I'm just going to include it like that. And this should be enough to get me started. If anyone sees anything obviously wrong.
Line 6, semicolon to comma.
Yeah, classic mistake, right? Yeah, I keep putting semicolons at the end there. Cool. So this should work now. Okay, so now if I run that same command, what happens? Well, we dropped the table, we created the table, and then we inserted, it looks like we inserted 4 things. I still wonder what that first 0 means, but I feel pretty convinced at this point the second one means how many things you added. I'm going to guess 0 is just a signal that means successful versus broken. We might as well test that out really quickly. If I leave out some information and I try and do that, what happens? well, it just doesn't, we're not getting anything back. So I do wonder. But okay, if this is what it is, I'm gonna run that. And now if I say select star from students, we see we have these 4 students. They have the information relevant, and they each have a locker ID, even though it's just a number. So what we've covered so far in this review is the basics of creating a table, dropping a table if need be, defining our table in terms of a schema, and then finally inserting specific, new pieces of data, new rows into that table. So we just want to stop for a second and say, how are we feeling about the essentials? Because I feel like sometimes when I ask, for feedback on this stuff, no one wants to answer because it's like, well, you don't want to seem like you don't understand an essential. But the truth is, that's often the hardest part, as in if you have any misunderstanding about the basic building blocks, anything beyond that will get, tainted by that confusion. So let's really make sure we understand this part. And that part just being the create and the insert.
One quick question on when creating, I think it's like drop table if exists and then cascade down. What's the point of that cascade statement?
Yeah, that's something I have to look up myself. As I've mentioned, I wish I had more genuine PostgreSQL knowledge, but this is where I often don't know certain more specific commands. So let me look that one up. So it looks like it is a type of constraint. Is that right? Cascade. I didn't want to make a bookmark. What's going on there? Come on. Just trying to search cascade. Okay, well, it's showing me it there, but where's the definition for it? There must be a good definition for cascade.
I think
And a
you
little-
had it on that page there.
Oh, it was on this page?
Yeah.
And a little context is it's Postgres deciding if we have a relationship between 2 tables and we delete one, what should we do with the related tables? Do we cascade that delete when we delete, say, if we delete a trainer, do we delete all their Pokemon?
Right, got it. Yeah. And it sounds like cascade is sort of the equivalent of let's say you're deleting things in your file system, you might say remove a certain file, but if that file had stuff in it, it wouldn't want to do the remove. So you add the -r, so you're recursively deleting from that file. So cascade seems to do something similar, which is it will attempt to delete that table, but normally it would say, hey, this table has these relationships set up. I can't just delete this table without breaking these other tables. So cascade will say, well, what I mean is delete this table and any table that is that has a relationship with it. Probably a pretty good operation. Go ahead.
I was just going to say with their students lockers example, we could change the cascade rule so that if a student is assigned to a locker, we wouldn't want to delete that locker. We would only want to get rid of a locker if we knew that no one had it.
Yeah. And let's keep that in mind because at some point we will create the locker. So let's actually see that cascade effect. And in my opinion, the most useful thing you can do when you're learning a new language, essentially, or even a new technology, library, framework, whatever, but especially when you're learning a new language, and that's what SQL is, you really just want to run commands and see what happens. And you want to use data that you're okay losing, because really the only computers are great in that way that you can find out what it does. You just, execute the command, but you generally only want to do that in an environment where you feel comfortable losing everything. And as some people mentioned, if I tried out that command of, dropping the Postgres database, I would have had to reinstall Postgres. That would have been a big mistake. So, there's limits to this whole just try it out and see what happens thing, but I would have learned something. I certainly would have learned to not do that anymore.
And what you're doing now is a great flow too of having the .sql file because then we can safely drop tables, drop databases, and then we have that code with everything that we kind of need there to refer back to, which is a great workflow when kind of developing and figuring out your data models and stuff for the first time.
Yeah. Okay, well, right now we have each one of these students and they have these locker numbers. Before getting into some of the, I mean, maybe actually, no, that's right. Before we get into anything to do with these foreign key constraints or whatever, let's just say this is all the data we have, and let's make sure we understand these other essential commands before we get into the idea of foreign keys and relationships. So first we have select. We've been using select star from students, and that'll get everything from students, but it's important we see the different things that we have access to. So instead of select star, we could put parentheses here and say what we actually wanted. I wonder if parentheses are actually necessary, because I could probably say select first name from students, and that would go through. It's almost as if you can read that that from first. So really what we're doing is we're grabbing the students table, and then we're selecting what from the students table. Well, we're selecting just the first name, and for whom? Well, because we didn't specify any kind of where statement, we're going to do it for everybody. And that's the first name for everybody. And notice that what it returned me is itself a table, but it's a table with just one row, or sorry, just one column called first name, and 4 rows representing just the values. And yeah, I mean, it's I just want you to note that you're always dealing with tables. You're always returning a table. So even if we had something here like select first name from students, and we added a where clause, which is sort of like a filter, we're going to say where, where what? Well, where first name is identical to, I would say Bill, but we actually wrote Bill. So cool. And this is getting off the screen. I can't even see it. Cool. So if I write this, interesting. Why does that not work? Isn't that
single quotes?
Single quotes, right? I'm always making that mistake. And as you could see,
that is the worst about it.
Well,
SQL, I have to agree.
It's interesting to see, because not every programming language is made the same, or not every programming language is as usable as any other. And like, you could just imagine if they gave me a useful error statement here, I would know right away. I would see like, not column Bill does not exist. Rather, you use the wrong quote type. But this should work now. And as you see, we got back still an entire table. That table simply has one column and one row, but it's still a full table. And that matters because just like with, a file, just like with Python, how everything is really an object, or with your file system, how everything is either a file or a folder, in SQL, everything is going to be a table at the end of the day. Okay. So where are we? We still have, select star from students, but we're exploring this select statement and all its, different approaches. So I'm going to ask a question of the class, which is, what might I write if I wanted to get every student their first name, last name, and birthday, or just how about just their first name, last name, and birth date, assuming and the filter we want to do it on is that they were born January 1st, 2006 or later. So does anyone want to volunteer to try and write this query?
So do you do like select first name, last name, birthday from students?
So before we continue on, this is the right way to do it. That we start with saying, well, what do we want to accomplish? We want to do a select. Well, what do we want to select? We want to select these 3 different fields. Okay, well, from where?
From students.
Yeah, so we're explicitly saying the database where these columns exist. Okay. And now if
And
I just
then-
did this, what am I going to get?
You're just gonna get the table for first name, last name, and birthday, but you wanted like students born after January, what was it?
I said basically let's just try and get these last two. So let's say born after January 1st, 2007. Oops, trying to move this. And I'm going to clean this up a little. So basically we're saying select first name, last name, birth date from students. Some people do prefer this style where you break it up. I like that. So from students, and then you were saying we need a where, right?
Right.
So we have our where, and then what do we put in the where?
I'm thinking like birthday. I don't know if we should do equal or like greater than.
Well, we
I'm
want,
confused about that.
yeah, we want everyone with a birth date greater than a certain date. So it seems like we want greater than. The real question is, will SQL understand? As in, if I say greater than, and then as a string, I give it a date of that same format, does it understand? So in this case, we were saying 2007, January 1st. So that, the first date in January, and we're hoping we're just going to get Cassie and David. So yeah, if we could take a poll, I would say, do we think this is going to work?
I think it's gonna work.
I think it's going to work too, but it is important to remember that like whenever you're dealing with computers, the compiler or the program, whatever it is, that's the real source of truth. So like if this doesn't work, then I learned, oh, I guess it doesn't work. So even if it should work in your mind, it's good to always test it out. But indeed, it did work. So that's the real benefit of the types in SQL, because if we, looking here at our definition, if we said this wasn't a date, but rather just a string, there's no way it could accomplish this because it doesn't know the string 2007-0101 is less than the string two. Maybe it would do okay because you still can compare strings, but it's much better than it knows it's a date. But yeah, this yeah, go ahead.
I was just going to say, I don't have a lot of familiarity with other database engines, but having worked with Postgres, it is pretty amazing in just giving you a lot, like being able to throw that string in there and compare it with the date and stuff like, and lots of nice date related functions and other things.
Yeah. And Postgres really is. I mean, I think it's the reason why we teach it and most boot camps teach it, that it's not everyone's choice always. There are simpler choices for a relational database, but Postgres is considered the most feature rich. From what I know, it comes from academia, so there's no company behind it. It really is just this attempt to see how rich you can make a database ecosystem, and in particular, it really doubles down on this idea of unique data types. So I know you can have like different money types, and that's really useful if you could, just say we're looking for, the situation where the money, the monetary type is more than a certain amount. And I don't know how powerful it actually gets, but like it might be able to see through or do the conversion for you for like monetary values. So the more specific it knows what your data means, the more heavy lifting it could do for you in comparing things. Okay, so this is what our select looks like. And this is basically what you want to see. I mean, the only things that you can really change here from what we've discussed are, what you care about. And you could always just have star and say, I care about everything. And then the where lets you filter. And then there's often other things you can do with that where. So in this case, I have, I'm selecting all that stuff. But what if instead of saying where birth date was greater than something, I wanted to say, what's something that'll grab more than one person? I don't think I have that. well, I mean, I wanted to show this idea. It looks like here we have this I like, which from what I can tell would be another command that lets us mess with a wildcard. So maybe to see that working, I'm going to first insert something. I'll say insert into students. And what am I inserting? Just got to look at my, yeah, so insert into students. All of
And
these.
the I like, it's a pattern. I think it's a pattern matching. It looks really,
Yeah,
if
I
I
believe
have that
that's what
right,
it
which
is.
I think is what you were saying.
Yeah, so we're just going to insert another row so we can see that I like functionality. So we're inserting another student with a first name, last name, birth date, and locker ID. And I believe I can leave off locker ID. That's allowed to be null right now. And then we'll give that values, and we're only adding one. So I'm going to say that first name and last name because I want to use this A. How about it'll be Adrian? Adrian Brody, remember him. And Adrian Brody was born in 1873, 09, 01. So he's slightly older than Chase, who we all remember as the oldest member of this class by a century or more. Okay, so let's do that. Insert something into there. Yeah, if you guys get to make fun of me saying Pikachu wrong, I can make my own internal joke. Chase is extremely old, maybe a vampire.
Thank you.
Yeah, so we're just going to see, okay, we do have Anna in there and also Adrian. And the point of all that was that so that I could have this statement where I say, okay, get the first name, last name, birth date, where. Well, what do I want to put in the where? The example we see here says where the first name. So it's being explicit about, it's saying students.first name. You only have to do that when it's ambiguous. So if you're doing some kind of join and there's multiple tables and they both have a field called first name, you have to say where table name dot field or column. But I'm just going to be able to say first name because there is no ambiguity. So I'm going to say where first name. And then I think there's a symbol for this too, but without using the symbol, I can say I like, which means for a string, it's going to match a pattern. And what is that pattern? That pattern is going to be a percentage. So percentage here is the wildcard. In most environments, you would have a star to represent a wildcard. For whatever reason, they have percent. And this is going to say anything that starts with an uppercase A, that counts for this filter. So doing this, we would expect to see both Anna and Adrian. Great. Yeah, and I could see, I actually, based on what I'm looking at, I could have a different situation where I say, well, what about where last name ends in Y? So we're going to have that wildcard in the front, and then it's going to end in a lowercase y. What do we expect we're going to get back from this? Which rows?
4 and 5.
Yeah, exactly. So David and Adrian. That's what we get. So that's a pretty powerful feature, wildcards. And the point of this is to see how select is very simple on the surface, but you have these additional parts you can add to the queries that allow you to be as specific as you want to be. So virtually anything you could ask can be contained in that single query, as opposed to having to query for something, get some information, and then use that in your next query. Yeah, and we've seen insert into is often going to be a little simpler than select, because you're really just going to name the fields you want to insert into and then their values. And unless those fields are null or a primary key, you can't leave it out. And its type is going to have to match the type of the schema. So there's not too much wiggle room with insert into. It's either going to work or not if that data is valid. And right, the other two we haven't seen yet are update and delete. So this is a pattern you'll see a lot. Like when we get into, when we get a little more into Django and backend applications, you'll see the same idea, which in backend is called CRUD. We sometimes call that creating a CRUD app. And I hate that term because CRUD sounds like trash or stupid. And who wants to be assigned to create a CRUD app, right? But CRUD just means create, read, update, destroy. And if you think about it, that's those are the 4 things you would ever do with data, which is create, meaning it doesn't exist yet and you're trying to create it. So create is, in SQL terms, insert. That means create a new row or multiple. Create, then read. So what represents read? Select is read for SQL. Select means not creating anything. I want to tell you what I want and you retrieve it for me. That's the read or get, whatever you want to call it. And then after create and read, we have update. So update is actually update in SQL. Update means it's sort of like create, but instead of creating something, it's sort of a combination of create and read, because create makes something brand new, reads something that already exists. Update will search for something that already exists, and then instead of creating new, you actually update what's there. So the example here would be to say update, the syntax is first update, then the table, so students. And what do I want to update at this students table? Well, I want to set a specific value. So let's say I want to say, okay, I have Adrian Brody here. He refers to locker ID 1. I actually want him to refer to locker ID, 101. So I'll say set, and then the name of the column, which is locker ID, and then the new value I want to give it, which is 101. But importantly, if I were to, put a semicolon and then hit enter here, what do we think would happen?
Every locker is going to get updated.
Exactly. Yeah. So by default, without a where statement, SQL assumes you mean everything. So whether it's an update or it's this or it's that, it assumes, unless you use a where clause, you mean everything. But the where clause is how we filter, and we say, well, we only want to do this operation on a few things, or maybe just one thing. So we actually want to just do it on one thing, and that one thing is a student. And that student has an ID of 5, but maybe I don't know that or care. But I do know this student has a first name and last name of Adrian Brody. And maybe I know that's the only student like that. As you could see, like, it gets kind of dangerous, as in we didn't say there's anything unique about having the name Adrian Brody. Someone else could have this name. And what I'm about to do will affect their, if there was another Adrian Brody in this table, maybe as he has a different birth date, a different ID, he's a totally unique person. He has his own locker. I would now be doing a sort of destructive operation that affects all Adrian Brodys. So ideally you do say where, ID equals 5. And that, because the ID has this primary key constraint, that's always going to be a unique person we're referring to. But let's say I didn't know that, I just had their first and last name. I could always, make a statement where I say, like, a conditional. So I would say where first name equals Adrian, and then and I believe is a keyword. Am I correct? So within conditionals, I can say and. So I want to make sure that first name equals Adrian, but maybe we have another Adrian. So I want to say and last name equals Brody. And then from there, I feel pretty satisfied saying, like, well, I'm pretty sure we only have one person in the history of this school named Adrian Brody. So we're going to set his locker to ID of 101, and this should work. Let's try it. We see update 1, so that implies we did something successfully. And then let's see. Yeah, so now Adrian Brody has a locker ID of 101. And then finally, in that CRUD idea, the final thing is delete. So just like you might create an element, you might want to delete an element outright. So how would we do that? Well, with update, we could kind of like blank these details out, or maybe give them a, so I could always say, like update students where, we're just going to say where ID equals 5. So let's say we wanted to delete Adrian. We would say, we're going to update students where ID equals 5. And what are we going to do there? Well, maybe we're going to set a couple things. So we're going to say set, first name has to exist, but there's no reason it can't be empty. So something like that. And then do I put like a comma here, or do I have another set after this? Like if I wanted to also set last name to null or empty string.
My idea would just use the and try that way.
Okay, yeah. I mean, we might have to look this up, but I mean, one way to find out the syntax is just to experiment. So let's say I said, where first name and last name equals empty. So will this even work? Let's try it. Invalid input syntax for type Boolean. I think it's I don't think it does like the and. Can anyone look up the syntax, or should I look up the syntax? We're looking for update. Update is a common one, and it's often hard to read these because they're trying to tell you everything you can do with that statement. But we're looking for something like update table name.
You can instead of using the and, you can use set. So set first name equals empty string, comma, last name equals. That'll work.
So you're saying a comma is what I want. Okay, that makes sense. So something like this, right?
Yeah.
Okay, so let's try that. And that appeared to work, where now we sort of blank this out. And if I went all the way, I would say something like where, first name and last name and birth date. I wonder if it will yell at me at some point for something not being valid.
Well, not the ands though, right?
Oh, right, not the ands. I'm getting confused. How did I oh, I guess yeah. But I mean, I don't really need to show that as much as I want to show that, like, if you do it this way, you can start to blank out an element, but you still have that ID there. You still have that row. And that's not great, because this always comes up when it comes to deleting things, that one way to delete something is just to sort of blank it out, but that even though you're blanking out the value, which is like all these rows, the key, the ID, the thing that represents something unique exists, is not going to get deleted just because you're blanking things out. So even if I made that ID, if I was able to make that ID like null, we'd still have a row there. So that's where delete comes in, that I'm able to say simply delete from students. And what do I want to delete from the students? Well, if I just wrote this and ended it with a semicolon, I believe I would delete everything in the students table. So I add that where clause. And the best way to delete something is with its primary key, because then there's only one of those. Okay, so let's try running this. And let's see it. Right, there is no person like that anymore. And then importantly, let's actually see if I try to insert into students. Always forgetting that syntax. So insert into students, and we want to grab, all that information. It's all of this that we want to insert into a given student, like that. And then I'm going to give it those values. We're only going to add one thing, so that one thing is going to look like maybe, once again, we'll add Adrian Brody. We can give it any locker number, any date, because we just want to have some data in there. Okay, so I'm going to end that with a semicolon, and now we inserted something. And if I look at it, notice this is pretty important. It does not have an ID of 5. It has an ID of 6. And this is one of those important reasons why you don't want to manage IDs yourself. You want to use that, primary key constraint, because primary key constraint will make sure that every time you add a new person, you're getting a brand new ID. And so in that case, if someone were to query for ID of 5, simply by the fact that there is no ID of 5 in that database, they know it did exist and it was deleted. Or rather, if someone were looking for ID 77, I could easily say, well, the latest ID is 6, so there's no way that person ever existed. Whereas if you were looking for ID 5 and you knew that you had an ID like 6 in there, then 5 was deleted at some point. And I actually find it pretty cool. I hope we don't see anything bad, but an interesting thing is that if you go to Facebook, you can kind of see this in action. Well, it's not Facebook J. That is not a popular website as far as I know. But if we go to Facebook, okay, we're actually going to get stuck at this part because I don't currently know my Facebook account or anything. But you can try this out yourself, where if you go to Facebook and you type like /100, if you were signed in, it would show you the 100th Facebook user, because that is the actual, it's able to look it up by ID. But you'll notice a lot of them, if you try and look for Facebook user 1, it's empty. Facebook user 2, it's empty. Only Facebook user 3 is finally a person. It's Mark Zuckerberg. But what that tells you is that Facebook user 1 and 2 were essentially sample things that he added to the database. And at some point he deleted them, or otherwise they weren't useful. They were just like test accounts. But that when he deleted them, they didn't actually get deleted, or at least their ID is still taking up that space. So he is the third user, as opposed to suddenly he's the first user, because those two don't exist. So that is the point of IDs and deleting, in terms of like maintaining a record of, okay, well, it's not in the database, but given what the ID is, it must have been at some point. Cool. Okay, so we've gone for an hour now, and I do like to give you guys breaks. So let's, right now, we're at 9:20. Let's just give you a 10-minute break, or we're at 9:20 for me. Let's give you a 10-minute break to 9:30, and we'll just break right now. And when you come back, if you have questions about the stuff, we'll go over it. Sounds good? Also, I want feedback from you guys. Like, does a 10-minute break feel useless? Would you really prefer just less often 15-minute breaks, 20-minute breaks? Like, because whatever time we give you guys for breaks, that can be split up however you see best. So we would like feedback on that. But for right now, take the break and write me on Slack if you have an opinion on that. And I'm just going to share the screen, start recording again. Let me, I always want to, how do I, oh yeah, I just want to click the participants thing, see some videos. Okay, once I see a couple faces, I know we're doing okay. We got some faces here. Okay, so we're back. Cool. Yeah, so what we covered so far was what I would consider these basic SQL commands of select, insert, update, and delete. And those 4 represent working with a single table. But in our situation, we don't just want to have a single table. We also want to have this idea of, relationships between tables. So the first thing we're going to want to talk about is join, which join is a way of combining tables, usually for the sake of a select. And in order to really see the usefulness of that, we're going to have to create the locker table now. And I see I see this. What is this? If I click, oh, that's just for the file. Okay, I was a little confused. But okay, well, I'm looking at this and I have this drop table if it exists students, and it has this locker ID. And I linked a bunch of things to these lockers, but I don't know what a locker looks like. So quickly looking through this stuff, I want to see at some point we do create a locker. And I just want to get a sense from this, what does a locker look like? So I'm positive we have an example at some point. Okay, here it is. A locker should have an ID, a number. Oh, so right, the locker number, as in, I guess beyond, I mean, that's a little silly to me, because in my ID, in my sense, if a locker has an ID, that's the locker's number, right? What else would the number be? But I could see how it could be different. Like a home could have an ID and then an address, even though the address is its key. It's its unique thing. And then finally, a combination. So I guess in this case, the combination is the 12, I guess, up to 12-digit code that represents the combo. Cool. So how might we write this? Well, I want to create this table lockers. So kind of before here, I'm going to have my drop table if exists lockers, which doesn't exist yet, but we're about to create it. So create table lockers. And like anything else in the world of SQL, our locker is going to have an ID with a data type, serial, and that will be the primary key. So that's how we refer to that specific locker. And then finally, I have I don't really want to give it a, yeah, might as well. Well, let's give it a locker number. Let's just give it all these a number that is an integer. Again, it probably, I feel like serial makes sense because from what I understand, serial is just a positive number. And someone correct me if I'm wrong, if serial means more than that, but there's no reason why the locker number should not, you know, we're never gonna have a locker number of negative 2078. So serial makes sense to me, but feel free for someone on the chat to say like, no, that doesn't make sense if it's not correct. And we're going to say that cannot be null because every locker is going to need a number. And finally, every locker is also going to need a combo. I guess that's how you open it. So we'll call that combo. And that we're going to store seemingly as a varchar. We haven't figured out how big that varchar is, but it's also going to be not null. Every locker has some combo to begin with. And when I think about it, so what is a, you know, a locker code? Well, the standard is basically you're going to have 3 numbers between 0 and 60, and then you go to the first number. And then after going to the first number, you spin it, like you spin it to the right to get to the first number, and then you spin it all the way to the left to hit the second number, and then you spin it to the right to hit the third number. So really, there's only 3 numbers, and those numbers are between 0 and 60, and we can represent 0 as like 00 and 60 as 60. And so there's no reason we would need more than 2, 4, 6 characters. So if we really wanted to cut it close, and also we can kind of make sure at this point that no one gives us a combo with, you know, 8 characters. So, I mean, it's reasonable to limit it here and say, oh, no, it's always going to be a string that is exactly 6 elements long, and that represents our combo. Cool. And this all makes sense to me. The final thing we would want to do is just insert some things into this locker. So I'm going to add down here, insert into lockers. And what are we going to insert? Well, every locker needs this number and combo, and the rest will come from ID. I see how it's highlighting this. I wonder if it's okay with me saying number. I don't think it's going to be, because number is a keyword for the type. So just to be safe, I'll call this locker number. And so every locker has a locker number and a combo. And then I'll give it the values, and I'll put more than one in there at a time, and the values will look like this. Just make it look exactly like that. And so what are these locker numbers going to be? Well, this will be locker number 100, and its combo is going to be, 1004 59. So I'm sure there would be a way of setting like a real constraint there, but that's okay. This will be enough. And notice I'm not giving it the IDs, but I could, which might make sense because I already have these, but we'll probably update them before we do that. So I'm just going to give it a few, maybe just as many, 4. Okay, cool. And then we'll end it with a semicolon. So we have locker 100, locker 101, locker 102, locker 103. So these lockers are all next to each other, and they just have kind of arbitrary codes. I don't know. It doesn't really matter. Okay, these are my lockers. So we're gonna run that line again with the /\I. And yeah, we're not seeing any issues here. We get this notice, but notice is not an error. It's just saying that table doesn't exist yet because we ran this line drop table if exists lockers. But now we should be able to query for our students, which are exactly what they were, but we could also query for our lockers. Okay, so we have all of our lockers, and you'll notice just like with the students, they all have an ID, and technically this locker ID should line up, but they don't quite line up. So we're going to fix that. And maybe we'll fix that real quickly right now, where we'll just say like, okay, well, we know 1, 2, 3, and 4 are real locker numbers, so we'll put those in here. So each one of these students has a, it's not enforced, but right now there's a one-to-one relationship between student and locker. So I'll run that again. And I'll see now, I have my students like before, but their locker numbers are between 1 and 4. And then these are the lockers from 1 to 4. Cool. So that was all set up just so that we could talk about this next idea, which is join. So before we get into sort of this foreign key idea or relationships, like we didn't explicitly say that locker ID was a foreign key, or that student locker ID was a foreign key to lockers. But we still have this idea of joins, which lets us combine tables, at least temporarily for the case of a select. So in writing this select, maybe I'll have, my normal select, and I'll say, well, select, let's just select everything. I actually want to see all the information for a given, row. And then where is it from? Well, initially we'll say it's from students. And that could be the end of it. And if we did that, well, we've seen this. That's just all of the students. But what a join allows us to do is that, continuing on from this from statement. So I have select star from students, but I'm not done. I actually want to combine this idea of a student with a locker. So you'll see here in this example of this join, I don't know why they do it this way, but they chose to do it this way, where they're saying basically they're saying s.id, l.number, and then you're able to say from students s, and you're just giving a short name for students called s, or a short name for lockers called l, which is useful when you want to distinguish. And they do overlap in that they both have an ID. And so, we couldn't just say, once we do the join, we can't just say, show me the ID, because they both have an ID. But let's ignore that, shorthand thing for now. We're just going to say join. So what do we want to join it with? We want to join it with another table, in this case, the lockers table. And I'm actually curious, if I didn't add the on, what happens? Like, can I just write this? Not quite, seemingly. So it's actually important that we explicitly say how we join things. We can't just smash two tables together. We have to say how they join with each other. So we're going to say join lockers. And notice we didn't say join, we didn't say inner join or outer join. We're just saying join, which I think by default means inner join. But either way, we don't have to worry too much about the specific type of join if we're not worried about null situations. So we're joining with lockers, and how do we want to do that? Well, we say on. So we say on, and we say, how are we going to match these up? Well, the student has a locker ID on it. And because it's the only thing, I believe I could just say locker ID. And then I want to say when locker ID from student is equal to locker's ID. But student and locker both have an ID. So I have to be explicit here and say lockers dot ID. And now I believe this will work. And as you see, it's a little large, but if I pull it out, I'll see, oh, I actually joined them. I have an ID representing the student, first name, last name, birth date, the locker ID, and then the locker ID and this, the locker ID is going to be perfectly matched to locker's own ID, 1 to 1, 2 to 2, 3 to 3, 4 to 4. And then for each row, we're getting that locker number and the combo associated. So that's pretty good. But still, I probably want to, I feel like it does deserve cleaning up a little. So I kind of like that we're going to say from students S, so we can be explicit there, and join lockers L, so we can be explicit there. And then I'll say, just to be explicit, S dot locker ID is equal to L dot ID. And then also, I didn't like how that printed out where we saw the ID for both. So I want to be explicit about what I'm selecting for here, but notice that even though we seemingly define them later, this L and this S, I can use that those symbols within the select part. So I can say I want S's ID. I want, now I have to, it's a little annoying that I have to say, first name, last name, because I would like to just say everything, but I want S dot ID, S dot first name, S dot last name. Sure, S dot birth date. And then importantly, I don't actually want to see the locker ID. I just wanted to make sure that the locker ID and locker's ID line up. So at that point, I'm not going to say locker, like S dot locker ID. I'm not going to say L dot ID. I don't want to see those. That's, the join is taking care of matching things up. So I want to say at that point, well, I want to see my locker number. And for completeness sake, we're also going to look for the combo. So now when I do this and I hit enter, is this not what I want? It looks a little odd.
You have to S comma birthday instead of dot birthday.
Yeah, that's probably it. Yeah. So small typos can make a difference like that. Let's see what happens if I do that. Okay, well, I'm still seeing this thing. Is it because I use parentheses and I think I don't want to use parentheses there? Yeah. So all the issues we're running into here, it's frustrating, but this is sort of a part of how programming works, that syntax makes a big difference. So those parentheses in this case mean something I didn't mean to mean. So now that I do this, I'm actually getting what I want. ID, first name, last name, birth date, locker number, combo. And yeah, I'm able to be as explicit as I want about the data I actually want to see. So before moving on to anything with this foreign key idea, let's understand join, because join is sort of essential to how all that foreign key stuff ultimately works. Where we have that one part that links, where there's a relationship between the value of a column from one table and the value of a column from another table. So how do we feel about this, this select we just wrote with join?
What was the L and S when you said like S first name and then you put L?
So the only reason, right? So basically here where I wrote join, instead of just writing lockers, I wrote lockers space L. And similarly with from, I said from students space S. So that's basically giving it a shorthand name, because otherwise all these places where I wrote S or L, I'd have to explicitly write students or lockers. And that can be, annoying to have to write that over and over. So this is just we're giving it an alias basically. So this is no different from, not writing that LNS, and everywhere where it's currently written, replacing it with the word students or the word locker. But that is, a lot to write out. Sounds good?
Yeah, that makes sense. Thank you.
All right, cool. Any more questions about where we are in terms of, we have those 4 basic create, insert, update, delete commands, and now join has been added on to select as a way of, combining 2 tables. So how do we feel about those 5 ideas together? Okay, I'm going to assume good, but I'll still look at the chat. Yep, and I see Daniel's mentioning some stuff that it's a little advanced, but a lot of stuff we end up doing in SQL, or once we get into the Python phase of things, you'll notice that we end up doing things in a certain way. And you might say, like, why not just write raw SQL in your Python code and execute it? Like, why do we eventually use this ORM thing? And what Daniel is talking about is sort of an advanced concept, but there are reasons to be careful with exposing, basically with giving sort of direct access to SQL, because there's this idea of a SQL injection. And what that boils down to is that if you let a user just type anything in, and then you use that as input to your, SQL query, the user can put some tricky things in if they're really smart, in such a way that a user can, I mean, it's a little too much to go into, but basically a user can sort of do a little Inception style stuff, and you think you're just giving them the spot of like where they could put in the ID, but they actually can put in a whole unique SQL statement in there and say, like, well, actually drop all tables, and then, try and do this thing. And so there are very like SQL is considered an attack vector for security stuff, and it's why you often don't want to, what I would call, roll your own. So eventually we'll be using an ORM, and part of the reason to use an ORM is that you don't want to be directly writing SQL, because you're probably opening up a little hole for someone else to just arbitrarily write SQL into your database. Cool. So yeah, this is what we have right now. And after join, we start talking about constraints. So we've seen some constraints already. We saw this primary key constraint over here. And what primary key did was make it so that that ID is understood to be the primary key, and it auto increments every time we create a new element. And that is a constraint. On some level, the data type itself is a constraint. You're saying the data must fit this sort of shape, otherwise I'm not okay with it. Not null is a constraint, because we're saying, normally a piece of data, whatever it is, it can at least be empty. Well, not in this case. We're saying not null. Unique is one. So for instance, I could say, I don't know, what would be a good example for unique? Like if I said, I mean, yeah, so example, locker number. Like we want to make sure that 2 people don't have the same locker number. So we could add unique in there. And if we were to then run it, get that file back. Okay, we created the same table, and I can, select star from lockers. I see these are all my lockers, but I said I have this constraint called this constraint called unique for lockers. So if I were to try and say insert into lockers, locker number and combo. And then we're going to give it those, those values. So I'm just going to try and add one thing in there. And that one thing I want to add is a locker number and its combo. And I don't really care about the combo that much right now. 1, 2, 3, 4, 5, 6. But this locker number, I said it was unique. So what if I try and create a new locker number, or sorry, a new locker? So it's going to have a brand new ID, but with the locker number of 103, which we see is already in the table. Right, got to add my semicolon, and then we get an error. It says you can't do that. And this is actually good, as in, even though we're getting an error, it's good to get explicit errors as opposed to silent errors, as in we want to ensure our database looks a certain way or our table looks a certain way. And this constraint kept us, or rather someone interacting with our table who might not know the schema that well, it kept them from accidentally putting in bad data. And it's way better to get this error and then figure out why your program broke than to not get an error and then later realize, oh, we kind of have corrupt data. Like, it's valid according to SQL, but it really doesn't make sense that two individual lockers can share the same locker number. So we kind of violated our own understanding of the data, the shape of the data, as I would say it. And so constraints are really powerful for sort of setting the understanding of what is and isn't valid. And that's really useful because the person who designed the schema is probably not going to be the only one ever inserting things into that table. And so the schema defines the real source of truth. And of course, in a real world application, you could easily have it where, like, the only one with access to alter the schema is like someone who has real authority, and then everyone else has access to add things to the database, but they can't alter the schema themselves. So that was unique. There is check here, as you could see. I mean, I'm not exactly positive how to use check, but it looks like we can set specific values on it. So let's just click on that. I don't even know that. So check. Yeah. I don't know that we have a good example for this, but if I want to say, like, okay, the price is interesting, numeric as opposed to integer, and check will say it's got to be greater than 0. So usually your type constraint will do that for you. But do we have any examples? Like, what might make sense? As in, let's say I have my locker numbers, they're serial, they're not null, they're unique, but I also want to say check. And what is it that I want to check? Well, in parentheses, I'll say locker number must be less than 1,000. So we cannot have, we're saying we only have locker numbers starting at 1 and going up to 999. Maybe I even have to say both of those. Like, can I say check something and something? Let's try that. Like, I'm going to say check. Someone can tell me if I'm writing this correctly or not. I probably want to do something like this, where I say the and in here. So I'm going to say check that locker number is, I think serial guarantees that it's going to be, let's just say, so we're going to say it's an integer. It's definitely an integer, but I'm saying that integer has to be greater than 0. You can't have a locker 0. You start at the very least at locker 1. You can't have more than locker 999. And we're going to create that, and all of our current values should work for that. Okay. And again, I can look at all my lockers, but now I'm going to try and insert into lockers. And I'm going to say, first, well, I actually want to create a locker with a locker number of -1. And sure, that's the combo. So what happens now? It doesn't like that. Why doesn't it like it? Violates the check constraint. So it's good to see that that was the issue. And then we'll try it again, where I'm going to say, 1,000. It's not going to like that either. And then finally, I'll try something that does work. If I say 999, that should work. And indeed, it does work. And I can now look at my database and see, okay, entry number 7 is locker number 999, and we didn't violate anything. So that's cool. what else is there before we get into foreign key? So, right, we've seen primary, we've seen unique, we've seen null, and we've seen, or rather, saying not null, and we've seen check. And the final thing is foreign key. And foreign key lets us, just like it with the join, foreign key is a constraint within our schema that lets us say this has to line up with another table, or by default, this number should represent the ID in another table. And by making SQL aware of that, it's going to have an easier time of linking the two when it comes to referencing them. I mean, if Adam is here, maybe he knows a little more about foreign key than I do.
Yes,
But
sir.
yeah, so I am actually curious, why is it necessary that you give something like, so down here, we're going to say, okay, well, we have these students, and it wasn't enough that locker ID is serial. I actually want to say it is a foreign key, right?
Mhm.
And then that's not it, right? There's more to foreign key that I have to say. I have to say about that foreign key, so it references something. So in this case, I'm saying product number is an integer.
There's, this might be more than one way to create a foreign key in Postgres. The quickest and the shortest way, I think, is the example where you see where it's using references.
Okay, so you don't even have to say foreign key?
That, I believe that's correct. That's the shorthand version. And then if you want to say foreign key, that's like the longer version for maybe if there are other constraints you want to add around that foreign key, or for some other reason that I would then have to.
Yeah.
Usually we can just use the shorthand for like your, standard everyday foreign key.
Yeah. I'm seeing here
references.
that so it seems like you can explicitly make a foreign key. Like it seems like maybe you use that foreign key keyword when you explicitly are making a foreign key out of some other.
I believe
columns.
references will actually, under the hood, apply that foreign key command. But like in that example, they were building a composite foreign key out of these two fields.
Yes.
And I think it's the more complex use cases where you have to explicitly use that key, because that's where the shorthand notation, you just hit the limits of using that notation, if that makes sense.
So
I would have to try it out to be 100%, but that's that, because I haven't touched Postgres in a minute, but that is my understanding.
Okay, so looking at this, it looks like we say, in the case of the foreign key, I think I lost it, but in the case of the, where is it?
Yeah, and I would recommend, it's so easy just to say references for the basic foreign key that I think the best practice is to start with that. And then if you have a more complex use case, then you shift to the other notation for doing it.
Yeah, and to be fair, I don't personally understand the use case in which I would use that other way. So we're going to ignore it for now.
Yeah,
but
it's like,
yeah,
composite foreign key is actually a good example. Like, I'm not sure if you could just say reference.
Got
it. Yeah, if you wanted to like to play with our example, I'm not sure what a composite.
I don't think it's worth getting into, because unless we can show a solid example, let's forget about it.
Thank you.
So anyways, we have locker ID here, and it references something. So we're being explicit in the table about this relationship. And we're saying it references first the table name. So in this case, lockers. This is why order of the schema can matter sometimes, because we really needed this lockers table to exist before we could reference it. And once we reference it, well, what is the thing we want to reference in lockers? We want locker ID in students to align with a specific column in lockers, and that column would just be ID. So having this as it is now, this will work. I should be able
I hope after I said all that stuff, I didn't totally miss something.
Okay, so I'm already getting something here. We're seeing insert or update on table students violates foreign key constraint student locker ID F key Why? Well, key locker ID equals 1 is not present in table lockers. So,
You may have to insert the values
Right.
prior
Yeah.
to reference.
say that one more time.
You may have to insert the values into the table. So that's why maybe there was a separate script that we used to first create the tables, then insert the data.
I think you may just need to insert the locker values before the student values. The students is trying to reference.
And that makes sense actually, because exactly like that. I think that is the value of this references approach as opposed to just doing it manually where we just had, you know, a value there. By saying references, when we try and add a student and say that student has a locker ID of 1, it's going to look up and say, well, is there a locker with ID 1 right now? And because of how we wrote it before, there were no lockers yet. So it instantly failed because it was saying, how am I supposed to associate Anna Abrams with locker 1? There is no locker 1. And again, that's the usefulness of a constraint, that we were able to get an error as opposed to just doing nonsense. So if I run this now, I see key locker number equals 100 already exists. Is that right? Is it because I'm not dropping tables? I mean, I am dropping tables. I'm a little confused. Duplicate key value violates unique constraint lockers locker number key. So what is going on there? I'm seeing that locker number needs to be unique. But what's the problem here? Every locker number is unique.
Should we do a quick select all on lockers just to see what's in there?
Sure.
Yeah. Okay. So yeah, you're right. It's the non-obvious.
Duplicate key value violates unique constraint. So let me check /D here. I wonder if the issue is that part of how this works is that it creates these lookup tables, and these lookup tables might need to be destroyed before.
I would have thought that would have been taken care of, but since I agree that that's certainly a possibility that somehow that's gotten out of sync.
Yeah, well, something I'm considering is, what if this is that cascade example? I need to get, I'm always opening new windows. It's kind of hard to see this. It's a little too much screen real estate used up doing Zoom and coding simultaneously. And so yeah, we had that cascade idea. I wonder if that cascade idea would do this for us. I mean, this seems about right. Dependency tracking, that is what we care about. When you create complex database structures involving many tables with var and key constraints, etc. Okay, so drop table cascade. So let's just see if that helps us. So currently we have drop table if it exists lockers, but I want to cascade that because it seems like we have some kind of lookup table that's related, and same with students. Let's just see if this makes a difference. So I'm going to do that again. Seems to like it. And now what happens if I, well, I guess we didn't get the error that time. Yeah. So I think that was the solution, is before adding that cascade, there were certain tables, which are being called sequence tables, which were created internally by SQL or by Postgres to link those things up. And I wonder, can we look in locker ID sequence? Like, how would I look in a specific table?
Yeah, you can do /DT, I think, and then the name of the table.
Okay. So we're going to try and look at the specific
something
table
like that. There's definitely a way to do it.
Sequence.
Maybe just try D with the name of the table.
Let's
There's
try
definitely a
that.
way to do it. All it tells you is what the next key is going to be.
Okay, I see. Well, I
There you
think
go.
the offending table then was probably so. Both lockers and students have the concept of an ID, and the sequence is a way of easily looking it up. But student locker ID sequence is going to be where they're actually associated with each other. So let's try that one where we're going to say students locker ID sequence. And when we look that one up, is that not what I want either? I'm just seeing, yeah, I mean, I'm not quite seeing, I'm not really sure right now why we were helped by using that cascade versus not, but it helped us in resetting those relationships so it no longer thought something already existed in there. Okay.
Did you want to, I'm not sure if we can do a select on a sequence if it's a special sort of table, but I wasn't sure if that's what you were thinking for.
No, I mean, I'm honestly
Yeah.
not sure, but I don't want to start getting into the topic of sequences because we haven't talked about it at all. And I don't
Agreed.
personally even understand it that well. So based on what we have right here, let's just stick right here. Everything we have right here is enough now, as far as I know, to create all kinds of tables with all kinds of relationships. So before moving on, the two new ideas we discussed are join and references. Do we have questions about those? It's not, it's honestly good to have questions, guys. It's unlikely you have no questions about this, but I do know what it's like to not be able to formulate a question. You don't know enough to know what to ask.
Yeah, if there's anything that anyone would like us, Benjamin, to go over again, or just, if you want to throw something in the chat. Benjamin, I just want to mention that was a great call to realize that cascade was the issue. And someone mentioned this in the chat as well. Dropping the database entirely is always a nice option to have. If it's hard to diagnose and figure out the exact problem.
Yeah.
As long as it's not that root Postgres database.
Right.
Yeah.
Oh, and I see I have a link from Adam that seems useful that I'm going to open up right now.
I was sharing this. A student from the previous platoon, Sierra, actually shared this with us. Registering is the only annoying part. It's actually a pretty great tool for visualizing SQL database table relationships.
Yeah.
And it should allow you to select Postgres, and it also allows you you can kind of ignore the diagrams and just create a new one. It allows you to upload a .sql file.
Okay, so how do I do that?
Yeah, I think if you hit new diagram and select Postgres as the type and just give it whatever name you want, and hit create diagram. And now there should be a file option. You might have to expand. You're going to have to expand the browser window. We're getting some cleverness. Yeah, and if you go to import, and now if you upload that .sql file, we'll be able to kind of see the tables and with a visualization of relationships. And you can manually add tables and columns and create foreign key relationships as well. The user interface is a little, it's pretty good. It has a few funky parts, but it's pretty good on the whole. Yep, and you can hit back to diagram and you should be good to go. I think this is where one of the funny parts where it looks like it didn't capture that foreign key relationship in the import. In order to make that, this is where it gets a little funny. There's a little hand icon in the lower right.
Yeah.
And if you click on that, and then you click on one of the tables, the whole thing. Oh, let's see here. Maybe I have it the other way around. It's there. There's one way to click on it where you then are able to draw in a connection, and I will fiddle with.
Okay, you can fiddle with it right now, but
Yeah, we'll
looks
fiddle,
like
yeah.
we're not. It's not instantly useful to us as a tool to see the relationship.
Yeah,
Um,
if you, I think if you unclick the hand, I apologize, the little green hand in the corner. Now try clicking on a table. Yeah, now you can grab the dot and drag it over to the thing you want to connect it to create a foreign key relationship.
okay, and
And
this
then you can select, yep. And you can choose one-to-one, one-to-many, whatever, by clicking on the little connection therein.
Oh, I see. Well, it looks like, right. So we have one-to-one right now. And what that means is every student has their own locker. But we haven't necessarily defined that in terms of some kind of constraint. So I see here it says, if we had this issue where, or if we have this case, we have a student and a locker, each student ideally can have only one locker, and each locker can be used by only one student. So there is it's important we say both, because even if you said each student could have only one locker, you might have two students who share the same locker. So it's because we have both statements that we're saying each student has exactly one locker, but each locker has exactly one student. So according to this, it's saying that the solution is that we have a foreign key that is constrained by being unique. So what does that look like? Well, here we have our table lockers, and there's nothing unique in there because the locker doesn't know about the student. It's the student who knows about the locker. But then here we say, okay, we have this locker ID. It is an integer in this case. It references locker's ID, but importantly, we're going to say unique. So if we didn't say unique, what would be a situation that might be confusing, that we might want to avoid? Well, right now we have, all of these students, and each one is associated with a specific locker. And, we're going to assume these are 1, 2, 3, 4, right? But let's say I wanted to say, well, actually, I want to add another student. That student, once again, is going to be Adrian Brody, because Adrian Brody is the most interesting person who's ever gone to the school. Let's be honest, you've never heard of David Derby. Well, maybe you've heard of Cassie Cage. She's from Mortal Kombat. But Adrian Brody is going to be the student we care about. And who really cares when he was born? But we're going to say Adrian Brody has locker number 4, which is the same as David Derby's locker. And is this going to be a problem? Well, to tell whether it's going to be a problem, let's look at our students' schema. Our student schema says locker IDs are serials, so they're numbers essentially, and they reference this table locker's ID. So the only issue we could have is if that ID didn't yet exist in lockers, but it should. So we're going to run this code. And we didn't have an issue, did we? It says notice. Okay, yeah, we don't have to worry about that, I don't believe. Drop cascades to constraint. Yeah, I don't really understand that, but now I'm going to just look up everything in lockers and look up everything in students, and we didn't have an issue. And what relationship are we creating right now? We're saying that one student always has one locker, but many students can share the same locker. So for one locker, you have many students, perhaps. And we don't like that because we want to say every student must have a unique locker. So what we're going to do is say not just locker ID, serial references locker ID, but I want to make sure I add it in the right place. Okay, so before we say the references, we're going to say locker ID must be unique. So no two users could share the same locker ID. Now we're going to run this. Maybe clear that first. And now we get a good error, or and that's the difference. A notice is just telling you some info you might care about. A warning means you're probably doing something wrong, but maybe you know what you're doing. An error means you're definitely doing something wrong. SQL will not work with you on this one. So the error is duplicate key violates unique constraint student locker ID key, because key locker ID equals 4 already exists. Okay, well, that's good to know, because we don't want to give Adrian Brody, a locker that already exists. Rather, we'll give him a brand new one. And in order to give him a brand new one, we actually have to create a brand new one, because there is no locker 5 right now. And we don't really care about the details of it, but it's locker number 104. So basically the way we're doing things forces us to add a new locker every time we create a new student. And that's the whole point of constraints, that they force you to go down a certain path, because otherwise, I think the most open version is many to many, which means a student could, well, I don't know, a student will always refer to one locker, but multiple students could refer to the same locker. Could multiple, I don't know. But basically that constraint is helping us notice when we're doing something that doesn't make sense given how our data is defined. Okay, so I see we're at 10:30 right now. We've covered, a fair amount of review stuff. In terms of this one-to-one, one-to-many stuff, we haven't covered it that well, I admit. But it is a fair amount to cover right now. I guess this might be worth looking. So I see this is a pretty complex database they're showing there, but I just wanted to look at the schemas. Where are the schemas? Oh, here. Okay, so what do we have here? Well, we have lockers. Lockers are their own thing. And then every student has a locker ID, which references locker's ID, and it's unique, which means for every student, there is exactly one locker, and for every locker, there's exactly one student. And then looking through here, a professor is its own thing. It has no foreign keys. And every course has a professor, and that professor can't be null, but every course references a specific professor. So what that sounds like to me, because it's not constrained by being unique, that means that every course has exactly one professor, but one professor could have multiple courses. So that's one to many in that direction. And that makes sense, right? That, a course, at least in this world, a course cannot have 2 professors simultaneously, but a professor might be teaching 5 courses at the same time. And notice how that relationship was not like, there is nothing in professor that says, here's all the classes the professor's teaching. Rather, there's something in course that says, here's the professor for this class. And using querying, we could quickly find out all the courses associated with that professor. And then finally, we have enrollments here. I see we're saying that, how does enrollment work? Well, every enrollment is associated with a student, and it's not null, which means that every enrollment is associated with one student. But because we're not saying unique, every student or multiple students I'm a little confused. I don't even know what an enrollment. I guess an enrollment is a relationship that is saying a student is associated with certain courses.
As in attending a class, correct?
Yeah, I mean, this is a pretty complex SQL statement, but we're saying that every enrollment is going to reference a specific student, but based on how we're saying this, even though every enrollment has one student, multiple students could share the same enrollment. Is that correct? What would that even mean?
I'm not sure about multiple students sharing the same enrollment. I believe this is, you're right, this is pretty advanced this is sort of functioning as a join table to allow many-to-many relationships so that I, as a student, can take both math and English and enroll in both of those courses. The foreign key constraint with that unique value there is to prevent me from accidentally like getting enrolled into English 101 twice.
I see. Okay, so basically enrollments are going to represent a many-to-many relationship where it's going to have a student ID and a course ID. And so you can have an enrollment with student ID 0 and course ID 0, and then you could have an enrollment with the same student 0, and now he's enrolled in course 1. And so you would have multiple enrollments to represent, you know, all the
Correct.
classes that a given student was taken, and you're going to have, you know, one student is going to have many classes, but there's no reason that, you know, those classes can't be shared by multiple students. So that's a many-to-many.
Exactly. The classes also have many students. You're totally right. This is a more advanced topic. I'm not sure how much we've looked at it.
Okay.
One join table is one term I've heard for the pattern for this.
Okay. But anyways,
I was actually just looking
finally-
at the same thing, and I see it's off a reference of the junction table. Because sometimes, like when I looked up join tables, it talks about the methods of joining tables. And so looking at junction table might be easier if you have trouble.
Oh, that is good to know. Thank you. I actually did not know that.
Yeah. Not sure I totally understood, but it sounds like you're saying that essentially a table is made behind the scenes to relate these two keys to each other.
Not so much behind the scenes as in actually, if we probably can't whip up a diagram for it, but
yeah, and I don't want to get I don't want to get
yeah.
too into the weeds because we have a half an hour left and we have the entire
Totally.
part of it we haven't covered.
The short version is, in order to create a many-to-many relationship in which you want to have some constraints, like we don't want our database to let me accidentally enroll into English 101 twice, but we want to have multiple students in each class and each student enroll in multiple classes. We have to create this additional table that's like the intermediary between the student and the class that like holds that relationship.
Yeah. Well, my attitude is we've seen the basics of how we can create these relationships. We haven't necessarily, I mean, it is somewhat advanced, but we haven't really demonstrated so well how one might enforce a one-to-one or one-to-many, many-to-many, and especially how one might know which is appropriate. But I think we have enough here that we've covered the basic ideas in a review, and we've gone a little over, I would say, in that I do want to make sure that we get to this part of it, which is basically how to start using SQL with basic Python. So we are going to fair amount of code, but we're going to look at this, and I'm going to give you guys a 10-minute break, and we'll come back at 10:40 and do that. Sounds good? Cool. So stop share for a minute. Cool. See you guys in 10 minutes. y'all.
Hey,
Hey,
Benjamin.
take this one or me?
I'll take it. I'm honestly, I was thinking the next thing that we have to tackle is taking a look at how to use SQL with Python with this Psycho PG interface. And that's probably about an hour-ish in length.
Okay.
And I was thinking it might make sense for us just to break early for lunch and then dive into it after lunch for a bit, to be honest.
That does make a lot of sense. Yeah. So do we want to come back normally we come back at 1:30 p.m. CST and then they start the assignments. So do we want to come back at 1 p.m. CST or do we want to come back 1:30?
It wouldn't be the worst to get a little extra time.
Yeah, people are saying 1:30. We recognize that we don't want to eat lunch, and we already did take up 15 extra minutes. So right, we're gonna give you a breakdown. We're gonna come back at 1:30, and Adam is going to cover this second part of the lecture, which is Postgres with Python.
Yes, sir. And thank you.
All right. Great. So I'm gonna stop recording and then leave the meeting so I can download that file.